A quick introduction. I am Vijay, CEO of Applied AI Consulting, and with me I have Gigi Nagarkar, who is the CTO and architect.
Now, what are we here for? In the last webinar series, we touched upon two important topics. One is about evaluating modernization readiness for applications, where we talked about identifying the need for modernization, developing a modernization strategy, and conducting a thorough assessment. We touched this topic at a very high level because that itself is a subject. That itself is a subject, and we talked at length about, and we spent more than 30 minutes, last webinar talking about building modern apps for resilience and observability, where we touched upon two of our, or rather three of our customer scenarios for each of the rehost, replatform, and refactor scenarios. And we talked about, one scenario where we decided not to go ahead with modernization because they were not yet container ready. So now we are carrying this, three-part webinar series to the third part of it, which is about event-driven architecture, building modern apps and solutions. Here we'll talk about serverless first approach. We'll talk about event-driven architecture, and we'll also talk about the kind of services that we have used to build the application for the customers in context that we'll cover today. Like, every webinar, what to expect from this? So this is our sixth webinar in the series where we have been talking about serverless. We are talking about database migration. We have been talking about, automated performance testing, all that, right? So in this webinar, like any other webinar, the expectation is that it's not a theory on app modernization. We expect the audience to know what app modernization is all about. This is not a sales pitch. We'll not talk about applied AI consulting. We'll not talk about any specific tools. We'll talk about the tools that we have used during the process, during the consultation and solution building. But there are other tools that we can use. It's more about what the challenges we faced, how we overcame, and that may help you in your journey. It is about our experience. It is about the challenges, and it is about the best practices. So by end of this webinar, my aim is that with INGG talking and covering the topic today, you should know exactly what does event-driven architecture even mean, how does it work, what are key benefits of using it, and that should be a takeaway. How to implement challenges, and the challenge would be learning from our challenges that we faced, and the mistakes that you should not make if we have already made, right? We have figured it out somewhere. But again, it's a journey. So I'm sure there will be something that would be new challenges that you may be facing as of today, or you are working on certain proposal architecture solutions which you envision a problem. There will be ample time for Q&A, and we'll love to answer them as candidly as we can, as per our current knowledge. If not, we'll always get back. So with this, we are already 4 minutes into the webinar. I hope that ting sound will decrease because people are joining in, so there will be less disturbance. So thanks again for joining us for the event-driven architecture, building modern apps and solutions. To start with, what is exactly event-driven architecture? And now a very small, definition on this, just to be on the same page as the way we will talk about in the further slides. Event-driven architecture uses events to trigger and communicate between decoupled services, and in common in modern applications built with microservices. So basically, what we are saying is that whenever there is a change in a state or an update, for example, in an e-commerce scenario, when an item is being placed in a shopping cart, there's a trigger. When there is an order update, when someone is querying for the order, whenever there is a returning and something on the POS site, it's an event, and that would trigger a communication between different microservices. And a typical event-driven architecture will have three components: the producers, which you see on the left-hand side, right? And this is courtesy AWS, the image that you see on the screen. You have event producers, which can be your retail website you are purchasing an item, or on an app you are ordering something or querying about something or chatting about something, or a POS site, right? Point of sale. You are again returning something or ordering something. So all these are the producers of the event. Events are getting produced at these different touch points. In our examples, when Gigi would cover, our typical touch points would be an email origination, a scheduling of an email, or an employee trying to swipe in his card, ID card, to get into a campus, right? These are the examples we are going to talk about, where we are talking about millions of data point, events getting generated. So they will be the producers in this case. In my current slide example, the events on these websites are the producers. They all talk to the event router, which has the intelligence of routing the event to the right consumers. And again, in our real example, we'll talk about the consumers, which will be in the world of emails and the IoT-based solutions. But in this example, the consumers are basically your database. It can be your ERP system. It can be your pricing and billing system. It can be your CRMs, whatnot. So net decoupled systems, distributed architecture, microservices, you know, event producers, routers, and consumers are the keywords that will be continue to use in our further discussions when we'll talk about event-driven architectures and building apps around that. So let's talk the real world now. All this was just a context setting. Let's jump on to the two use case scenarios, which we would try to spend more time talking about and hoping to get questions from you guys. So number one application in context today is AI sales assistant. It's a SaaS-based solution used by today close to 200 customers across globe, processing millions of emails every month. This is built with event-driven architecture, and technically it involves uploading leads data in Excel, Google Sheet format, where as a user of 7 targets, consumers or the customers have say thousands of emails where they email IDs where they want to send email. They upload that data in an Excel or Google Sheet format on 7 target solutions. Then the emails are scheduled and sent as per the schedule. There are intelligent email-based follow-ups. Then the responses are classified after reading the content in the email. So this is an NLP solution which uses natural language processing and generation to read and then also auto generate the responses, categorize them into right response categories. And then based on a classification event, for the processing of the leads, right? So a lot of these are the events that triggers one or other action into different nano and microservices that we have built around this 7 target solutions, and then a lead enrichment. So with this context, Gigi, I'll let you talk more about the architecture, the design, and also how event is coming and how it's getting processed and challenges you have faced.
Sure. Thanks a lot, Vijay. I hope the context is set, but let me put in a little more detail in terms of numbers there. And guys, feel free to type in any questions that you have. And like Vijay said, it's an experience of what we have done, what we have learned, what are the problems, are some of the important points that we handled, or we looked at, and how did we handle it, right? So putting in some numbers around the data there, right? Because I mean, when we're talking about event-driven, one of the important factors that you have to look at when you are designing and architecting such a solution is to look at the scale of the events, the size of each of the events, and the frequency of each of the events. So here, we today are processing like a million, close to a million, or a little more than a million emails, or sending those many emails every 2 or 3 days. That's the load that we are at present handling. Around 30 to 35% of the emails are open. So every email opened is an event that is received, right? So that's so I'm going to along with the numbers, I'm also going to the aspects of various events. One of the first events is after sending the email is a notification or an event received that this email is opened, right? Or another type of notification that is received is there's a link that is clicked inside the email, and a lot of the time emails are also opened by bots, and links are also clicked by bots. So this number goes from 30, 40, 50%, and you have to handle that load. Once the email is open, then you would get responses. So received response is also an event that you get. And those could be a lot of emails as well. Yes, in actual human written responses, the numbers are low. If you are in that domain of sales and marketing, you know the numbers are low in the range of 5 to 7, 8%. But because there are a lot of automated emails like out of the office and others, this number goes to 15, 17, 18%, depending on what are you doing and when it is being sent, right? And before all of these events are received, one important event that happens is the loading or uploading or bulk uploading of the emails or leads to which the emails are to be sent, right? And now in a bulk upload scenario, if somebody is uploading 1,000 different emails or 1,000 different email IDs, then they would need to be processed. They need to be sequenced in the flow for them to receive emails, right? So that's the important point that we face. Processing of this bulk data, uh, you, I mean, you have to worry about, and we had to worry about the Lambda timeouts, which is 15 minutes at present in AWS. Um, and there are at least two ways or three ways we were thinking, how do we handle it? We handled it in one way using or breaking it up, but breaking it up into various batches and processing each of the batch um, in Lambda, but running parallelly inside a step function. So that's sort of a way that we handled. They could and there could be two more ways, but this is the way that we picked up. Why? Because we wanted idempotency all in place, so that if there are any failures, not just in this event but any other, and that's the last point. If you note, we have to be uh, we have to make sure that if it is restarted, it does not cause, it runs fine even if part of it or completely of it is processed, right? So we had to handle that. But in some other implementations, we discussed, or some approaches that been discussed was, let's run the Lambda before it times out, rerun it, stop this one as one of the options, a very rudimentary option that was looked at. Another option is forget about timeouts of the Lambda. Once you have the bulk load, start a container, and then I mean in a cluster like EKS or ECS, and then let it run till the time it processes completely, right? Depending on what you want to do, depending on if you want to divide the workload, you can batch it up and divide it into various batches. But you could start those many containers and not worry about timeout. So that's one important point we had to worry about when we are processing the bulk upload data in this case. While this is happening, we had to worry also about the um, triggering of the serverless functions, right? I mean, how many you would trigger, how would you how do you take care of concurrencies, and how do you take care of hitting the limits of parallel, and how much limit you should put in, all right? So depending on the number of events and the frequency of the events, getting it through via a queue or via a notification service help manage that well. That's what we did, and it helped us a lot, because for a situation where via some third party notification, if there are a lot of notifications that are coming, and third party also, I mean, in a webhook scenarios, in third parties like HubSpots or Stripes would have some control around, if you are not able to respond back within this much time, then we'll resend the notification, and we'll resend it this many times, and one notification may contain sizable amount of payload or workload, right? So to handle all of those, we had to worry about along with security aspects, we had to worry about how many parallel triggers or executions from these events are allowed and configured, and that's where uh, we based on, so there is no quick clear answer to start with, that this is the number that we started with. Uh, we evolved and continue to evolve over time. We continue to watch. So that's where logging and taking care of, I mean, securely logging and looking at the logs and creating a dashboards around the logs to know what is happening, what is failing, what is not failing, to continue to evolve these configurations was important and is important, and we continue to do that even now. Uh, one more important thing, or one more thing that we did uh, in this architecture, was to use the incoming. So let's say there's an incoming email, right? Let's simple out of the office, or somebody saying, let's connect after 2 days, or somebody saying, I mean, at present we guys are not looking at such a solution, but let's talk after a quarter or 2 quarters. Right? That email is like if you have understood or heard about NLP, and possibly everybody would have heard about NLP these days because of chat GPT. uh, the the email that is received contains a lot of information. It contains signature, it contains the body, it contains salutation, it also possibly contains the earlier email to which it is replied. So we had to apply some model to extract the core body. Now, uh, I mean, one more aspect to look at when you are using event driven is the cost consciousness. So we were conscious because because the number of the times the model had to run, or the inference had to be, the model had to run was only when the email is received, right? And it need not be run, or it need not be kept up. The APIs or endpoints of the model need not be kept up for the whole day, or 24/7, because it would be used only when the response is received. And that's where the cost was an important angle. And we used this event driven and then the serverless to do the inferences, like extracting the body or classifying the intent. Is it out of office, or is it something else? That sort of a thing, right? So here we face the problem of the size of memory at deploy time, like, and we heavily use serverless as a framework to manage and deploy the endpoints, or deploy the lambdas and endpoints for us, or services for us. So there we got into the problem of the size of the package that needs to be deployed, and we divided. Then looking at that, it made sense for us to divide that into layers. And so some of the core libraries that were required were put into a different layer, which does not change often, like scikit or some of those, right? And then only the piece that was required, or only the model that is generated, that was deployed into a custom container in serverless. And that's where we were able to manage the deploy time memory, or deploy time memory and size requirement. While runtime also, it was taking a good amount of memory, but now lambdas and serverless have come up with increasing, or allowing more and more memory. That is not too much of a problem these days. But the deploy time is still is. But now we're slowly moving to even using the I mean, some of the other services which allows to do the model, or build the model and use the model in serverless manner, right? SageMaker and also, that's a natural movement there. But till it was not there, and we continue to use this in some of these areas. But that, I mean, if you realize or not, that's an important point that possibly comes up almost every other place, where the data that is coming in is coming in a form of an event getting triggered, and you are not going to be required to keep your AIML layer running always. And only when that particular event comes, you go and try and infer something out of the data that is coming in from there, right? So that's an important point for us to use there. Security and logging, I think I covered, and idempotency as well I covered. But test-driven approach. So while we are doing this, it became pretty clear that unless we have a good amount of coverage of all of the code that is getting written, like 80 to 90% of coverage from the unit test, we would not be able to get that level of black box testing done very well, and various scenarios. And that's where um, there was a huge focus on making sure that whatever are the services, and whatever are the, I mean, lambdas or any other thing that you're writing and getting that code is getting used in the event-driven architecture has to be tested for various events, and different events has to be even tested for idempotency, and we were able to get those built in the form of unit tests running in the pipeline, which helped make sure that we are able to like upgrade prod once or twice or more times in the day easily and quickly when required. So yeah, those were some of the important points. I'm not going to read through some of the services that were used, uh, but um, and you could view them and very clearly see them. Some of those third parties were also very important for us, be it HubSpot or Zoho or any other thing that we're using, where the things were, I mean, receiving a notification from this third party is one angle, but if you are even making a call, so debounce is one service that we use to validate the email before we start sending any email, and the debounce service itself could be down, and that's where the lambda does not allow you a very good control over retries, over how often you want to retry, and how many times you want to retry, and you don't want to retry on this thing, this failure, but you want to retry on this other failure, right? So that's where this other service that you might see there in terms of step function was or is widely used in the processing where you want to control and bring in the idempotency as well.
Okay, I think thanks, Gigi. This is a good detail on how we use event-driven architecture for the 7 targets. I think at this time, let me move to the application 2. Very interesting application. We did it for one of the large IT services MNC, where we had to build a scalable solution for the real-time events. Those who are into the IT, I mean, most of you understand that in a bigger ODCs, we have to swipe in and swipe out our cards, right? And this is pre-COVID era. So with COVID, work from home, I'm sure a lot of us have not pulled out our ID cards for a long time. But yeah, so at that time, this is pre-COVID, 1.8 lakh employees, they had to swipe in, swipe out data from various controllers. Controls are nothing but the swiping machine that is in front of the doors, right? And this MNC had offices across globe, more than 40-50 offices across globe, all had different controllers because big buildings, multiple controllers, right? So close to 1.5 million swipes a day across 8,000 controllers located across India, and 50-60 offices or more. The whole purpose was to make sure the end business goal was that women's safety, because sometimes women remain in the office alone for the late night work or supporting the US clients or clients in different geos, and wanted to make sure that there is a security guard, there is no untoward things happening inside, and that was primary thing, and then other analytics and data on top of it, right? The overall swipe in, swipe out. So the goal was to provide insights on all the data that was being collected through the sensors, keep the data 14 days hot, so that employees can override the data, or administrators can also override or ask for more details from the employees. Employee could see the data for 3 months, and a notification to HR and manager instantly the moment it finds that any female employee is in the office alone, or without security and whatnot. So that was the high level goal. Now every swipe in was an event, and then the other data inputs and all, right? So Gigi, let's throw some more light on how did we do it, and anything you want to talk about.
Sure. Yeah. So I mean, again, the architecture diagram is there. You could this is an architecture that was deployed based on a lot of discussion with the customer, with the AWS guys as well. There could always be changes or refinements or thoughts that could differ, and we can continue to use some or other services. Not like this is the only thing that has to be used, but this was the architecture that was used then. One important focus around time on floor and time in campus data that we got in was the sensitivity of this data, sort of seen as the personal data, because along with that there was demographic attributes attached, and it became pretty, I mean, a hard requirement in terms of what needs to be like masked, what should not be masked, and all, right. That's one angle of it. But if we look at the intent of the application and intent of the solution that was developed, it was uh, it was clear that um, the provider or the user wanted to know if any woman, if any employee who's woman is at risk, because at a particular time, uh, uh, is there anybody else on the floor? Do they have the group, or are they alone? Sort of to make sure of the women's security or women's safety, right, in the offices at least. Or if somebody has started, then what has done, have they come back or not? All of those use cases were discussed, and so the real timeness of it was a super important requirement, and that's an important point which I wanted to make there, right? Because if there is a delay of 5 minutes, then the delay of 5 minutes is a huge delay in a scenario like this, in a value that is expected from a solution like this, right? So, and 5 minutes is a big time, but um, so some of those decisions that were made were best keeping that in mind, and using a lot of caches and using a lot of near the geography sort of computes and storage components. But even then, there was a latency from the endpoint, or from the controller which sends the data from that endpoint to the receiving point in the solution. It was a um, a Kinesis stream on which the data was received. So to the receiving endpoint, there was a delay there was a delay because of network latency, uh, and for whatever reasons, right? I mean, that delay was in the range of 200, 300 milliseconds a lot of the times, which was okay, possibly because it was still not in minutes. The processing time was always 100, 200, not more than that. So everything was done within uh, within few seconds, sort of, and not beyond a minute or so. But it had to be, and that's an important point that you have to think of when you are, or at least, I mean, if we had to do it again, we would have possibly paid a little more detailed analysis upfront before going the path of serverless. Is what is an important learning that we all felt when we did this, um, because of the severity and because of the criticality of the real timeness of this application of this solution. And uh, like possibly anybody would do, the events here were a lot more than a million every sometime, or every day, or less than a day as well. I don't know, because there is a period where a lot of events will come, the morning times, the lunch times, and the evening times, and all, right. So uh, so that batch of events, we had to, even the size of one event was less because the data in that was less, but the number of events were high, and so a bus or a event stream bus and Kinesis was used to make sure we're not dropping any. Monitoring if there are any drops, and putting right monitoring solution was the right monitoring, not a monitoring tool such, but the right things in place to know if any data, all the events are guaranteedly delivered or not, making sure that matching input and output pretty often. uh, so some in-house solutions were put in place to make sure nothing is lost beyond even Kinesis, or beyond any of the streams that we have. um, One important aspect in such a data processing solution that we came across, and possibly you may know, is to use the prefixes correctly in terms of storing the data for good performance while querying the data from S3. The data was queried in dashboards, or live dashboards we created in QuickSight here, and that's where it was important that, and like I said, right, the real timeness. So it became more important that the data is stored correctly with right prefixes, in keeping in mind that what is viewed and how is it viewed and how is it divided or managed well, right? So that's using the right prefixes is a critical aspect or learning that we had then when we did it. And yeah, I mean, I think we talked about concurrency and throttling earlier as well. So I'm not gonna ponder on that more, but a very good focus on the real timeness help make sure that we use the right things even at the storage beyond the events that are being received and processed and cleans and harmonized before they are stored as well.
Thanks,
Yeah.
Gigi. I think this is good. So I think critical thing recap here is that we had to make it real time. So Kinesis stream was used. Guaranteed delivery was a key concern here. So we had to work build a solution around that, and then we used Lambda and EMR to make sure that it's processed and the right dashboards and insights are shown using QuickSight. With this, I think we have covered two applications that we want to talk about. So key takeaways, right? And so one is when to use event-driven architecture, right? So Gigi, you want to cover the next few slides about key takeaways? Yeah.
Yeah, sure. Thanks. So, and this is again summary of some of the points that I covered. But let me read through so that I mean, and then ask questions. We might not have mentioned some of the points here, but I think we have covered it earlier. So, cross-region batch data processing, like some data is getting uploaded, and that processing needs to happen in the background. And if there is a delay of 4 to 5 minutes or more, it doesn't matter. It's not a live application. It's not a web application where somebody is logging in, creating some record and wanting to see within few seconds and all, right. So such type of things, yeah, it helps. That reminds me of one scenario where for us it is failing uh, every now and then in the event driven, where we using Cognito for a user sign up, and Cognito has this uh, pre sign up, post sign up like events which triggers the serverless lambdas, right. And then it has its own startup time or init time, the cold start time, right. And if it has its own restriction of able to complete the processing within like 5 seconds, right. That's a hard limit from Cognito and failing there. uh, but this reminded me, and I wanted to see if, I mean, I wanted to bring that point up so that it possibly helps someone else making the right decision there, right. Real time, if it is a key requirement, I would, I mean, we'd recommend not to. uh, but from a processing perspective, after the event is received, if the right components and right services are used, right caching, right structuring of data and all, it doesn't create a problem. uh, but unnecessary discussion gets on it in terms of, hey, is it the start time that is causing an issue and all. The network latencies from the origin point to the landing point is I mean, doesn't become or doesn't so you would get sidetracked, and that's why I would recommend not to do that. Wherever there's a need of fanning out and having that elasticity requirement, no doubt helps a lot. Um, Keeping the cost low, because those things happen only few hours or few minutes in the day, right. And that's why helps keep the cost low and helps use the elasticity aspect of any cloud really well, right. You have to, yes, state monitoring, alerting is an important aspect. If something happens, what do I need to do, and how can I do that? All of that is really possible. Integration with any third party heterogeneous systems, like exposing a webhook, or or getting a notification and processing the notification, even if the notification contains a sizable workload, right. It's We've been extensively using it, be it Stripes or be it HubSpots or Zohos or any of those third party. Easy to build, easy to maintain in silos, as well as deploy and modify, zero downtime, right. That helps a lot. So yeah, so those are the things that you would have to possibly look at when you are deciding when to use. um, so now, once you have decided what are some of these aspects, and these are self explainable, I'll still try and see if I can throw in some example somewhere. If you yourself think that some more things or points should be mentioned, please go ahead and comment or here, as well as maybe on some of the other LinkedIn event or somewhere, so that it will help us. add, and will put your name as a contributor there, no doubt about it. But while adopting, uh, some of the aspects or some of the architectural aspects that you have to worry about is the durability of your event source, right? I mean, is it reliable? Is it always going to make sure that if it is haven't received that the event is successfully delivered, then is it going to send again? All of those are important aspects that you have to worry about. Um, the performance control requirement, you should be able to handle the asynchronous nature, right? And these are coming in asynchronous. You should be able to receive it, maybe put it in a processing queue or notification service somewhere, so that whoever is sending gets a signal that the event is received, and then you handle it in a synchronous manner, right? The event flow tracking is an important thing you have to worry about. Um, so that's one, yeah, that's an important aspect. And then what is the data that is coming in your source, right? Like I said, there could be sensitive data you may need to mask. Will you be able to re-trigger if it is duplicate? What will happen? Idempotencies take, I mean, you have to worry about that and make sure you are building idempotent solutions there, right? Because there is a good flexible control that some event not getting processed, I will be able to go and re-trigger again easily. uh, but you have to make sure your code is, or you're writing code like to handle those scenarios. So yeah, so those are some of the architectural or design aspects to worry about. And yeah, benefits are pretty clear. These are not only four; they are much more. I know you know it more than these four, but yeah, uh, ease of scale, quick quick development, ease of deployment, and without any zero down. I mean, with zero downtime. If it fails, get notification, go and re-trigger. It increases your possibly support load, but it also helps you manage the support well, in my mind, because there could be failures, whatever good or bad code you or your developers write, there could be failures, and then it should be handled. But if it is in a very distributed way and event driven way, you would be able to trigger the event and re-trigger the flows, and you re-trigger the processes and all that. So that helps a lot. Uh, you would be able to at the agility of development, the cost is a clear takeaway which is possibly seen. Uh, but these events and segregating them in the landing event buckets, putting an intermediate or a processing or processed, all of that data lying there, the set of tools existing in the ecosystem helps to audit, to look at the logs, to dashboard really quickly. You don't have to worry about building new solutions around it. So that's where, um, I mean, a lot of time is saved, and you get a good amount of benefit there. Yeah. So let me pause there. I think we covered a lot. If there is any specific question, feel free to put in. Unless Vijay, you have something else.
No, I think, thank you, Gigi. I think we are good. We have spoken for close to 40 minutes. So, we have still 5-10 minutes to answer any questions now or over the mail. So, anyone, any questions? We would love to hear, or any feedback.
While I'm waiting, one of the questions that I have come across multiple times when I'm even talking physically was, or is, hey, can I get to know how do you run the model in serverless in Lambda? And there are good amount of blogs. I think we also have a blog on applied AI. If you're interested, you could go to the blog and take a look at it. Feel free to drop a mail if you need to know more there. While we are moving from that to now a serverless SageMaker, we may even open that blog up for others to look at. And we are extensively using serverless. So yeah, so we also have, again, not a sales pitch, but just an FYI. We have, because of the need of creating a standard way of creating new APIs and creating and exposing or creating lambdas and events and handling those very well, we have created something called as serverless API generator, which helps us develop or get the API production ready within like half a day, once you know the resource or entity and its corresponding attributes and types. So yeah, thought mentioning might help. if somebody wants to try and give it a use, reach out. We have not yet opened it, but we can give it to you to try and use it.
So if there are any questions, we are still around. If not, I think we call it a day, and thank you for attending this webinar.
Thanks a lot, guys, attending and being there till the end. I mean, giving 30 minutes or 40 minutes of your time is very, very appreciable.
Thank you.